Good morning. This is where we're going to get to today, but I want to show you how to get there. So we'll just hit start, and you can sort of see that we have one LED blinking, and so I'm going to show you how to get here. So we're going to stop simulation. We're going to close that panel. We're going to delete everything, I guess. And we're going to take a look at a part of this program or website, I guess, that you haven't sort of looked at unless you did it on your own. So we've looked at all and basic, and now if you look at all these different starter circuits, some of these we've done already, and you can just drag them out and you can play with them and see what's going on. This is using a potentiometer, and if you hit simulate, I would imagine that it's going to get brighter. And stop simulation. So because we're connected to the center pin, we have positive and negative. The negative is common ground, and we have some sort of resistor in here. We can basically move this dial, and we can get it to light. And that's because there's a breakdown voltage in the LED. But I'm not here to show you that. I'm just showing you that you can grab stuff from this panel and just goof around with it. Okay, so that's the basic starter, and you might be able to see. Let's start with all, and you can sort of see all the different ones. And that may or may not be interesting to you. But it's something, if you're ever bored, you can take a look at. There are circuit assemblies. I think that they're probably going to add to those. Microbit is a different controller, and you can look at that. So if we were to pull out the most simple example, maybe is the light one. And then if you look at your code, you can kind of see that there's special GUI, I guess, graphics that you can pull out. So these are all LEDs, and you can probably access them in different ways. I'm not going to spend a lot of time on it just because it's a little bit harder to make use of this kit, but we have used them, or I have used them in the past, so it's interesting if you wanted to do that. And we'll get rid of that. So that's the microbit, and they're changing. And the one that I really want to look at is the Arduino. So I would hope that you're not just going to hand in somebody else's assignment, such as this, but you can sort of take a look at, there's a whole bunch of different scenarios. So if you're bored with the pace that I'm going with, you can always play with these setups. But I will give you an overview of them. So the first one we're going to look at is the very first one. And you kind of see that the ground rails and the positive rails are tied together, and that we have 5 volts going to the red. So anywhere in the red is going to be 5 volts, and anywhere in the black rail is going to be ground. And if we open the code window, now it could be messed up from other ones, but it isn't, so that's good. So it's kind of saved my code from last day, and maybe I'm going to have to change that, but we'll continue. There's usually a lot of comments in here, and that's what I was hoping to show you, and maybe I'll just drag another one out. So let's just drag this fade out, and then we'll take a look at the code for that. So we look at code, it's going to ask which one. It's giving us this graphic version similar to Scratch. If I change over to text, then it kind of warns me because it's a one-way trip. And you can see that there's a lot of extra. So anything that's colored for up here, these are all comments. So the way you read it is these 2 slashes is a single line comment. So it's telling you that this is kind of C++ code, which is serious code. And then the next line is just a blank line. So I'm not sure. You can delete those. So this is basically called dissection. Now, this character here just is kind of like a wildcard, and you can see that there's a wildcard here and a wildcard there. We use it for multiplication, but essentially a / followed by that character means that there's going to be a multi-line comment. And then this is how you end it. So it's kind of like a mirror image of each other, but they're still forward slashes. So in this case, you could read it over and you can delete it just to simplify the code. And now we're left with essentially, I got rid of I. You are down to essentially what the code actually is. So this is declaring an integer. That's what the int stands for. So that's a particular size of memory, and we're going to set it at initially 0. So that would be the brightness of the light. And then you can have spaces that are white, or you don't have to have them. You can delete them. It depends on you. Sometimes it's good to have them separated just for readability. You have to have certain components. So like we need this set up. You'll notice that it doesn't follow with a semicolon or end of line, and that we typically have an open brace and a closed brace. And if you get rid of one by mistake, it's not going to compile. So if we were to run this right now, it should run. But if I was to stop it and delete one of the braces, then when I tried to run it, it would give me an error, and it would be saying that it's looking for this. It's expecting that there's one more of those things. So then if you put it back, and it's on the keyboard by the enter command, and you have, so that's a square bracket, and then this is the brace. So now if you run it, it should run fine. Okay, so 9 times out of 10, you're going to have an unbalanced number of braces, and that's going to be a problem. The other crucial thing is that you have to have a semicolon after certain types of lines. So you'll notice that they're throughout this program. You have another comment. So this is a comment here where it says what this is. So it says that we're waiting for 30 milliseconds. So that it takes 1,000 milliseconds to make a second. So this is a fraction, a very short fraction of a second. And you can delete those. You don't have to have them in your program. It is good habit to write them, but sometimes you just want to get things done quickly and you don't want to do that. Okay, so now this is a for loop, and it has a very specific method. So we have basically this declaration, which is a revisit of this one. So you could probably get rid of one of them, but it doesn't declare it as an integer. You could actually declare it as an integer here. And then after that, it's got a semicolon, and then it's got a brightness. So this memory allocation that starts at 0 is going to be here, and the way you would read that is less than or equal to 250. And then what's going to happen is it's going to tell you every time it goes through the loop, what is it going to do? So in this case, it's going to take the value that is current, so in this case it's 0, and it's going to add 5 to it, and then it's going to run it. So even though this is 0 at the beginning, it's going to increase it. So this analog value, which just means it's not on and off, it's actually some degree of on and off, on pin 9, so you can see that it's on pin 9, has a brightness level of whatever this statement is at. And you could write a display that shows you where it is. And then after that, it's going to pause for a very brief time. And then the second for loop is actually going to be doing the reverse. It's going to take the value of brightness, it's going to make it equal to the highest level that we're going to use in this program. And then it's going to ask the question, is brightness greater than or equal to 0? And if it is satisfying that condition, then it's going to keep going. And then the next time it runs through, it's going to drop it by 5. And then it's going to display the LED at that value on pin 9, and it's going to pause. Okay, so that's how you dissect a program. And if I delete that, I think that it'll get back to where we were. And we can bring our setup in. So at this point, we're going to go back to all, and we're just going to grab our good friend, the resistor, and we're going to grab an LED, which is location down here. And we're going to just hover over the end. So cathode is the negative, and that's why I have this resistor in the negative rail. And the positive anode is in the on the right hand side. And so I'm going to set it to pin 12. So pin 13 is the built-in, so it's linked to this one. So we're going to go to the other one, and we're going to change the value of the resistor to something like 220. So the last lesson we were talking about resistor values, so we're going to keep that. So then we're going to go take a look at our code again. Okay, so if we run this, we expect it to basically flash on and off every second. So if we look at the code, we have this compulsory setup part, and what that does is it declares that pin 12 is an output, and that implies that it could be an input, and that's what we're going to look at. And I think we've already looked at that with the when we had the little tact switches set up. So we're going to just do a text version of what we've already done with hooking up multiple LEDs. And then this part right here is where the work gets done, and it just basically means that whatever's in between these two curly braces, that's what's going to get done over and over and over and over again. So in this case, we're going to do a digital write, which is either on or off, not like analog write that we looked at in the previous example. And we're going to take pin 12, which is what we've linked it to, and we're going to turn it high. We're going to wait 1 second, and then we're going to take pin 12 and turn it low. And so that's what the text is saying. Now, if we wanted to add another LED, we can just copy this. So Control C, we can click in, we can enter, and it gives you a little indent, which we don't necessarily want. And let's change that to pin 11. So now we have 2 pins declared as an output. And we can copy this as well. It saves us typing. Copy. It is good practice to type, but we don't have to. And we can just copy it down here. And then this one we can change to pin 11. And this one we can change to pin 11. And so now we have it high and high, so that wouldn't do anything. So let's make this low. Low. And you'll notice that this is all in caps, so that's very important. And we hit play, nothing's going to change because we didn't add the hardware part of it. So we're going to stop the simulation, we're going to close our code, we're going to grab another LED, and we're going to copy this resistor. So Control C, Control V, and we can move that over. Now you'll notice that this wire, if you double click on it, you can move it so that it's not, I don't know, in the way. Maybe that's a better place for it. Now there isn't a joint, so it's not actually joined on that sort of bus bar or whatever you call it. And then we can just run a wire, and we can change the color if we want. So now we have 2 LEDs, we've changed our code, and we hit play, and we got them both working. Okay, so now in this case, we have them both blinking fairly slow, and because flashing lights is always fun, we could change the value. So I can very quickly change that to 100, and let's see if we can actually see that happening. And now we got them flashing back and forth. Okay, so your task is just to basically go all the way. Now these last 2 pins, we can use them, but they're used to program the device. So now we are actually in a simulator. So if we're in a simulator, sometimes things don't work exactly like they would. You can also use these pins here. You can use them as pin numbers 14, 15, 16, 17, 18, and 19. Some of them are just inputs, some of them are also outputs. But if you want to, you just can kind of continue along and go from 2 to 10, and then you can just add them and you can have them flashing differently. If you wanted to, you could copy these 2 lines. I'm not simulating right now. And I can paste them. And so then let's grab, and we'll make this one 10, and then we'll make this one 9. And you can take this here, And probably the best way to do that is to copy the whole thing and paste it in, and then copy the whole thing and paste it in. And then what you can do is you can change this to 10, this to 9, this would be 10, and this one would be 9. So once you have that set up, then you could actually copy this whole chunk of them. Control copy. Now beware of this brace, and you can control paste, and then you can hit enter and control paste again. So now we have a situation that will hold true for 1/10 of a second, and then we've got another situation that will hold true for 1/10 of a second and all the way along. So we could very quickly have maybe all of these low and this one low. So we're going to have 12 on, we're going to have 11 on, this one will be low, so this one will be 10 on, and then the last one we want is to be 9 on. So make sure you're doing caps, and then low. Okay, so there's probably ways that you could do this with a little less language, but this should work. We're going to just add the hardware to that. And we can copy the resistors, Control C, Control V. We can double click, move that out of the way. We can add, let's go with another color, and whoop. Okay, so that should be the hardware. We'll go back to the code, we'll hit simulate and see what happens. So that's kind of fun. You can keep going and see if you can maintain all your code, keep track of all your curly braces, and see what you can come up with. You can also play with different sequences. If you want to be brave, you can take a look at that for loop, because for loop will maybe make some of this a little bit easier to write. Anyways, good luck with that and have fun.